All right, hey guys, today is Thursday, May 7th. So we look at our calendar here. This is where we're at. We're going to start lesson 18 today. Obviously, if you solve problems and questions about dividing decimals here, please let me know. I'm more than happy to help you. I know that it's kind of went through quickly. We'll come back and review some of that stuff later on, though, just to get some extra practice. Um, Looking at the next lesson, though, you might notice here that I go from page 375 to 376, and then I skip some pages, then we go to 383, 384. That's because I don't think this is going to take us very long to get through this, because we've already talked about a bunch of these concepts earlier this year. Now, if you fall into one of the boats where you're like, man, I really don't understand it, I'm not getting it, I don't remember you talking about this type of thing, maybe you're not with us out when we talked about it, some of these concepts, that's fine. Just know that you have extra pages here, some of these extra pages to get some extra practice and work on it. And then you need to come see me, okay? Come see me during our class hours. And if you can't see me on a certain day, see me the next day, right? But make sure you come see me no matter what questions you might have. And even if you have questions that go back to one of these older pages, like I'm happy to answer any questions you have, just come see me. So let's look at this. First of all, our learning target for this lesson, this is lesson 18, exploring fractions of division. Our learning target here, refocus this for us, okay, is that I can interpret a fraction as division of the numerator by the denominator, solve problems involving division of whole numbers leading to answers in the form of fractions, okay, or mixed numbers. All right, so if we look at this problem here, it says, Mrs. Tatum needs to share 4 fluid ounces of red paint. All right. Okay. She needs to share these equally, that's a key word, right? Equally amongst 5 art students. How many ounces of red paint will each student get? Okay. This is how much she has, right? This is what she has. She has 4 ounces. Now she's sharing them amongst 5 students. Okay, so the idea is that she has this paint here. This is 4 ounces, right? And she's going to share this amongst 5 people, right? Hey, I'm a student. I'm a student too. Anyway, you guys get the picture, right? That's what this is actually saying. Now we're not going to use this dash solve. We're just using it to make sense. I have 4 ounces. I'm going to give an equal amount to each one of these kids here, right? Well, you might realize right away that, hey, there's more students than ounces. Can't do it, right? Just can't. Of course you can. We just know that the answer is going to be less than. We know our answer is going to be less than 4, right? Whatever that answer is going to be less than 4. Not less than 4. She's like, what am I thinking? It's going to be less than 1. Whew, sorry. Of course it's going to be less than 4. It's going to be less than 1, right? Obviously. So let's go ahead and look at this. Yep. Let's go ahead and draw a model just making sense of what we're talking about here. The idea is that if this bar represents 1 ounce, okay, let's do that. And this bar will represent, you guessed it, 1 ounce. This bar is going to represent 1 ounce. This bar is going to represent 1 ounce. So there's 4 ounces, right? 1, 2, 3, 4 ounces. Now I'm going to divide these into 5 groups, right? Well, obviously I can't break them into wholes because I only have 4 holes. So one way I can look at this, I can break this into 2, 3, 4. So there's 4 parts. 5 parts. 1, 2, 3, 4, 5 parts. That means each one of these kids is going to get one of these parts. So we can go ahead and just label these as A, B, C, D, and E, right? If we do this, maybe this is Adam, this is Bill, this is Candy, this is Derek, and this is Ebert. Sure. Okay. Each of these is a kid, and each one's going to get this amount. So of the first ounce, each person's going to get 1 out of the 5 pieces because we're dividing it into groups of 5, right? So if I do the same thing, 3, 4, okay, there's A, B, C, D, and E. Do the same 1, 2, 3, 4, A, B, C, D, E. 1, 2, 3, 4. This one's a little bit wonky. A, B, C, D, and E. Okay, so now I've just divided them up. The question is, how much does each student get? Well, I'm gonna grab a different color here just to show this. If student A has these pieces, right? And each student does have an equal number of pieces each, right? They all have 5 pieces, right? Okay, so the idea is that, oh, sorry, they all have 4 pieces, right? Oh, sorry, it's been a struggle today. Each of them has 4 pieces because there's 1 in each piece for them, right? Okay, but the point is that this value of this piece, the value of this one piece right here, the value of this one piece right here is 1/5, right? It's 1 out of 5, so it's 1/5 ounce. Okay, this is 1/5 ounce. This is 1/5 ounce. This is 1/5 ounce, right? So the idea is I have 1, 2, 3, 4. So I have 4 of them. I have 4 1/5 ounces, right? Again, we could just use addition, repeated addition, but this gets us to 4/5, correct? This is a 4/5 of an ounce. So each kid gets 4/5 ounce of pink. So how does this connect to what we're actually talking about? Fractions as division. Well, in the problem, I have 4 ounces that I'm dividing amongst 5 students, right? Again, I have 4 ounces. I'm dividing them amongst 5 students. And according to this, my answer is 4/5, which is correct, right? It's 4/5. The point here is that we can look at this, we can look at division and fractions are doing the same thing. Fractions are just another way to write division, okay? And to model that, okay? So again, 4/5 is equal, 4 divided by 5 is equal to 4/5. And this is your visual evidence to prove that, okay? Another way we could possibly look at this, I guess, is we could go ahead and break this up like this. Go 1, 2, 3, 4, right? Okay. And so if you look at this as my 4, oops, if I look at this as my 4 ounces here, right? We can go ahead and break each of these up into tenths. So if we use this idea that I'm not going to be able to fit this. 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, one more, 10, right? So if I did use this strategy, and if I continue to do this, I could do the same thing. The idea is that each student is going to get a certain amount. So I'm going to break this into groups of 5, right? I'm going to five groups of 5, right? And so if I go ahead and actually, let's go ahead here. Stop. Sorry about that. I had to sort a few things out here, but I think we're good to go. So the idea is if this is 1 ounce, again, just like we had talked about before, this is 1 ounce, right? And these are tenths. So the idea is I broke these up, and because the problem is going to be, I'm taking 4 ounces, and this would equal 1/10, right? 1/10 of an ounce. Okay, so each one of these is 1/10. So then this would be total here would be 10 tenths, right? If I did the same thing here, 1, 2, 3, 4, 5, 6, 7, 8, 9. If I did the same thing here, this would be 10 tenths. This would be the same, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tenths. This would be the same thing, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 10 tenths. It doesn't need to be perfect for what I'm just trying to model here. The point is that 10 tenths, 10 tenths, 10 tenths, 10 tenths, this equals 40 tenths, right? So now I have 40 tenths, which is the same as 4, right? We know this, okay? So 4 is equal to 4.0 or 40 tenths, right? And so in this problem here, I'm taking that 4, right? And I'm going to divide it into 5 groups. So if I'm taking 40, I'm going to divide it by 5, okay? the idea is that I know using multiplication, I know that 5 times blank equals 40. I know that answer is 8, so I know that's going to be 8 parts, right? Okay, so that is it's 1, 2, 3, 4, 5, 6, 7, 8, correct? That would be A. That would be Adam or Alex or whoever that person was, right? 1, 2, 3, 4, 5, 6, 7, 8. That'd be the next person, correct? Next person would have 1, 2, 3, 4, 5, that's 6, 7, 8. Getting sloppy here, but that's all right for time's sake. 1, 2, 3, 4, 5, 6, 7, 8. That'd be the next person's. The last would be these 8 here, right? That'd be the last person's. So as you can see, we have person 1, person 2, person 3, person 4, and person 5 being divided up. And what do we get here when we solve this? Well, we would get 8 tenths, right? The 8 tenths, which is equal to 0.8 or 8 tenths. So what we're saying here is that 8 tenths, this is equal to 8 tenths. That 4/5 is equal to 8 tenths. Now, if you don't like, oh, well, that doesn't make sense. No, well, yeah, it does. If we make equivalent fractions, if I make 4/5 into an equivalent fraction, and I want to get this to tenths, right? To just so that this is tenths and this is tenths, I would multiply this one by 2 and multiply this one by 2. And guess what? 8 tenths is equal to 8 tenths. And therefore, we simplify that to 4/5, it's going to be the same thing, right? And so, some different ways to look at this, but the point here is that we can just look at a problem like this, a division problem. We can write any division problem as a fraction. Any division problem we can write as a fraction. And sometimes we have situations where we can write as a fraction, then we got to switch it to a mixed number. But we've been practicing that a bunch in school this year, so hopefully that's pretty easy. And quite literally anything could be written as a fraction just to represent it. So the goal is hopefully that this doesn't take us a long time. We don't have to spend a lot of time talking about this. And that's the main point, okay? Again, as you saw within the school here, is that numerator A over denominator B is the same thing as numerator A divided by denominator B. So A divided by B, okay, is going to equal A over B, okay? So again, fractions are division. Division is fractions, okay? Let's see here. On this page here, okay, I'm gonna have you go ahead and kind of work through this. This is all you really are required to finish today. First, so it's like I said, today's a pretty simple day. It's a more of a concept day than anything. It's rather than getting a lot of practice, it's more of a concept. Make sure you understand that concept, okay? Now, I didn't write for you have to do this page here, but I am going to give it to you just in case you want to write it down to help you understand it better. This is just a review of a lot of these concepts. So these are the, you can pause your video if you want to write these down. Again, it's not a have to. These are all review vocabulary, fraction, division, expression, quotient, and remainder. All of this is review, okay? But it's something that you can use if you so choose to use it, okay? Otherwise, that's all I really need for you to work on today, and hopefully you understand how fractions are division and division is fraction. They're doing the same thing, just how we write fractions. So, and hopefully, if you have questions, you'll come see me so I can explain that, because once you understand this, it's going to make a lot of our life moving forward much, much easier as well, okay? So when we get back here for tomorrow, then we're going to be on page 3. We're going to jump ahead to 383, and we're going to be actually just practicing these concepts, okay? And hopefully I'm not moving too fast, and I apologize, and we'll adjust if we need to, okay? All right, I think we're good. Awesome, guys. Yeah, talk to you guys later.